हेलो फेरि हामी अर्को भिडियोतर्फ जाउँ। यो चाहिँ हो आइसोथर्मल प्रोसेसको र एडियाबेटिक प्रोसेसको वर्क डन अनि इक्वेसन अफ आइसोथर्मल प्रोसेस र इक्वेसन अफ एडियाबेटिक प्रोसेसको बारेमा है। यो भिडियोमा हामी यति मात्रै गर्नेछौँ। यो चाहिँ एनईबीको स्टुडेन्ट्सहरू जो साइन्स लिएर पढ्नु भएको छ, त्यसैगरी डिप्लोमा इन्जिनियरिङका विद्यार्थी भाइ बहिनीहरूले कक्षा 12 मा कक्षा 11 मा चाहिँ टपिकहरू हेर्नुपर्ने हुन्छ, पढ्नुपर्ने हुन्छ, त्यसका लागि बनाइएको भिडियो हो। आशा छ अन्तिमसम्म हेरिदिनु होला भन्ने आशा गर्दछु। अब यसमा हामी फर्स्टमा हामी कहाँ जान्छौँ त भन्दाखेरि फर्स्टमा हामी आइसोथर्मल प्रोसेसमा जान्छौँ। आइसोथर्मल प्रोसेस, आइसोथर्मल प्रोसेस। अब के हो आइसोथर्मल प्रोसेस भनेको हैन त? that type of thermodynamical process in which temperature kept constant. Temperature kept constant. Okay, that type of thermodynamical process in which it is the type of thermodynamical process in which the temperature is kept constant. Okay, or dt equal to 0. Temperature constants mean temperature is constant means that change in temperature is 0. There is no change in temperature between system and surrounding. That type of thermodynamical process is known as isothermal process. If we have the system, here we have the system in which pressure, volume and temperature. Here the temperature is kept constant and pressure and volume are changeable. Okay. Now for isothermal process, we have the equation of first law of thermodynamics from first law of thermodynamics. Okay, dq equal to du plus dw, or dq equal to du plus rdt. Here the rdt is kept temperature constant, so the temperature is constant, dt is 0, so dq equal to du. This is the valid relationship for the isothermal process. Okay, again, now first of all, equation of isothermal process. Equation of isothermal process. We have for ideal gas equation. For ideal gas, the equation is PV equal to nRT. Here N is constant, R is constant, gas constant, okay, constant, and temperature is also constant for isothermal process, so that PV is equal to constant. Okay, PV equal to constant. If we have two systems, P1, V1 and T, and another system, it is changes to the pressure and volume are changes to P2 and V2, and temperature is keeping constant from one state to another. If we are changing this system one from another, then for both of the system, P1 V1 equal to constant and P2 V2 equal to also constant. So from these two equations, we can say that P1 V1 is equal to P2 V2. Okay, this is the generalized, this is the equation for the isothermal process. PV equal to constant. One equation is this, PV equal to constant. Generalized equation is this, and P1 V1 equal to P2 P2 is also the equation of isothermal process. Okay, now for work done in isothermal process. Okay, now work done in isothermal process. For work done, we know that W equal to P dV, dW equal to P dV. Okay, small work done is given by P dV. If we are plotting the graph between pressure and volume, then the graph which shows this shaded area is P dV, and this one is the work done. And this work is done from V1 to V2. So the total work is given by W equal to integrating dW from V1 to V2, and which is equal to integrating from V1 to V2 P dV. And also we have the relation PV equal to constant. Let this constant be K. Wait. Also, we have the gas equation PV equal to nRT, or simply we can say the PV equal to RT. PV equal to RT or PV equal to nRT, same thing. Then from this equation, we can calculate the value of P nRT upon V. Okay, this is the equation second and this is the equation first. Substituting this value of P in equation 1, we get putting the value of P in equation 1 here, then we get, if we put this value to here, then we get the work done W equal to V1 to V2 nRT by V dV, or which is equal to, this N is constant, R is constant, and T is also constant for isothermal process. So nRT is constant from V1 to V2 dV by V. Now this integration from V1 to V2 and this dV by V is also nRT, and this is log V. Okay, this is log V from V1 to V2, and by calculating or by solving this value, we can get the final result as V2 by V1. Okay, this is the equation of work done for isothermal process. This one is the work done. Again we have P1 V1 equal to P2 V2. Then P1 by P2 is equal to V2 by V1. If we write this equation in terms of pressures, then this equation becomes W equal to nRT log, this one is log E, okay, log E, okay, log E P1 by P2. Okay, this is also the equation of work done in isothermal process, where in terms of pressure, this is the equation in terms of pressure, and this is the equation in terms of volume. Okay, this is the work done in isothermal process. Similarly, if we moving forward for adiabatic process. Adiabatic process. Adiabatic process means that type of thermodynamical process in which the change in heat or rate of change of heat is kept constant. That is the dq equal to 0 or q equal to constant. Q equal to constant. For this, from first law of thermodynamics, dq equal to du plus dw. Then this is 0 means du plus dw, which implies that dw is equal to minus du. This is the equation for, this is the condition for the adiabatic process. Okay. Now, okay, again, equation of adiabatic process. ल अब हामी इक्वेसन अफ एडियाबेटिक प्रोसेस निकाल्न गइरहेका छौं। यसमा हामीले के कुरो के थाहा पाउनु पर्छ भने है फर्स्ट ल अफ थर्मोडायनामिक्स जान्नु पर्ने हुन्छ। अर्को गामा सीपी बाइ सीबी, ओके, दिस रेशियो मस्ट बी नो, यो चाहिँ हामीले जान्नै पर्ने हुन्छ। फर्स्ट ल अफ थर्मोडायनामिक्स dq equal to du plus dw, we must know this equation, and after that we can solve for the equation of adiabatic process. Okay, now suppose an ideal gas is taken in initially in pressure P1, V1, T1 is this one, you can write there. Okay, I'm just doing the mathematical terms only here. Okay, for that, from first law of thermodynamics, okay, wait, dynamics, from first law of thermodynamics, we know that dq equal to du plus dw, or which implies that du plus dw equal to 0 for adiabatic process dq equal to 0. Okay, now also we know that also we have du equal to cv dt. Okay, du equal to cv dt. This cv is molar heat capacity at constant volume. Okay, and dw equal to pdv. Now substituting this value or putting this value in above equation 1, putting these values in equation 1, we get cv dt plus pdv equal to 0. Now again we have from equation of ideal gas, okay, from the equation of ideal gas, PV equal to nRT, or just we can say PV equal to RT for n equal to 1. Now this is for molar, also you can say this is for molar. Okay, now integrating, now differentiating both sides, we get PdV plus VdP. This is chain rule, okay, for this one. Okay, first of all we have to write this one. Okay, wait. Okay, we can write derivative for PV equal to derivative for RT. Now applying the chain rule, PdV plus VdP equal to R is constant and RdT. Now we can put the value of dt here, that's why, which implies that dt equal to PdV plus VdP divided by R. Now substituting this value in equation second, we get substituting this value in equation second, we get, if we put this value in equation second, we get right here CV dt plus PdV equal to 0. Substituting the value of dt here, CB times PdV plus VdP divided by R plus PdV equal to 0. Now taking the LHS, taking the LCM, we get CV PdV plus CV VdP plus R PdV equal to divided by R equal to 0. Okay, this multiply this R to there equal to 0. CV PdV plus CV VdP plus R PdV equal to 0. Now taking these two terms as together, CV VdP plus CV PdV plus R PdV equal to 0. PdV common. CV VdP plus CV plus R PdV equal to 0. Okay, dividing both sides by PV, we get dividing both sides by PV, we get CV VdP divided by PV plus this CV plus R. Okay, from Mayer's formula, this CV plus R, we can written this as CP. Okay, CP. Then CP PdV divided by PV equal to 0. CV dP upon P plus CP dV upon V equal to 0. Again, dividing by CV, we get, or taking as common also, you can say this, dP upon P plus Cp upon Cv dV by V equal to 0. dP by P plus this Cp upon Cv equal to gamma, okay? This Cp upon Cv equal to K, what? You can write gamma. dV by V equal to 0. Now integrating, we get integration dP by V plus gamma integration gamma dV by V equal to 0. Gamma is constant also, you can write this outside also, gamma. Now further we get, again here we are, okay, CV integrating dP by P plus integration gamma times dV by V equal to 0. Oh wait, integration here also, then okay, again one time, dP by P plus integration gamma dV by V equal to integration 0. Okay, then or this integration is log P plus gamma times log V equal to constant. You can say constant here, or log P plus log B power gamma equal to constant, or log PB power gamma equal to constant, or taking this log another side, PB power gamma equal to E power constant, which is also a constant. So for adiabatic process, the equation is constant. Okay, PV power gamma equal to constant, where gamma equal to Cp by Cv. This is the ratio of molar heat capacities. Okay. Okay, this is the equation for the adiabatic process. Okay, this is that's for you. Okay, take ल आजलाई यति नै गरौँ। अब बाँकी नेक्स्ट भिडियोमा हामी गर्नेछौँ। यहाँसम्म चाहिँ पढ्नु होला। धन्यवाद।